Welcome to our analysis of some really critical source material, where we try to move past the headlines and get straight to the foundational ideas.
Exactly.
And for this particular exploration, just so you are experiencing a unique two-host AI conversation powered by Google's Notebook LM for deeper, more dynamic essay analysis.
And today we are embarking on a really deep intellectual journey. The subject, on the surface, sounds quite technical astronomy, but the insights we're after are purely philosophical.
That's right.
We're going to be dissecting some key excerpts from Mortimer Adler's introductory essay on astronomy, which you can find in the Syntopicon, Volume 1.
And when you hear astronomy, you probably think of distant galaxies, black holes, maybe the James Webb Telescope. But Adler completely flips that script. He's not really interested in the technical details of modern astrophysics. He's much more interested in how the study of the heavens functions as a great idea.
Yeah.
So our mission today is to explore how Adler uses this discipline, not just as a science, but as this critical window into the underlying structure of the cosmos.
And maybe even more profoundly, into the magnificent power of the human mind itself. The power to discover and then articulate order within nature.
Right. It's that articulation that's key.
That's the crucial distinction here. For Adler, astronomy isn't some siloed, objective field of study. He sees it as the longest, most continuous thread in all of Western intellectual history.
The longest thread, that's a big claim.
It is, but he backs it up. He demonstrates how it connects the primal pre-Socratic speculations, the meticulous structure of classical Greek cosmology, the immense theological debates of the medieval era, and the revolutionary physics of the early modern period. He just folds them all into one continuous, sprawling conversation about reality, about truth.
So if you're not just calculating planetary orbits here, what is the bigger question we're asking?
The question is, what does the sustained, disciplined observation of the heavens tell us about reality itself and our place within it?
Okay, that context is what elevates it to a great idea. It's paired with cosmology and, I guess, with the whole world of nature.
Precisely. The Adlerian framing dictates that whenever humanity tries to discuss the motions of Mars or the distance of the sun or even the shape of the galaxy, those questions always double as these foundational inquiries into the structure of the universe as a whole. You can't just hypothesize about Jupiter's movement.
Or not.
Because you immediately have to confront whether the universe is finite or infinite, or whether its matter is perfect and divine or imperfect and terrestrial like ours.
I see.
That mandatory pairing of observation with metaphysics, it just elevates the stakes of the scientific field considerably.
Let's start with that then. The sheer status Adler gives this subject. Why does he put astronomy on such a high pedestal in the hierarchy of knowledge? What gives it this specific dignity?
Well, Adler argues that the dignity of the subject matter is paramount. He gives astronomy such a high status and treats it as an exemplary discipline because of the scope and majesty of what it studies.
The scope and majesty.
Think about it. It's a science that deals quite literally with the entire physical universe that we can see. It studies bodies, the stars and planets, that appear eternal, unchanging, and governed by these perfect, predictable motions.
Right, unlike things down here on Earth.
Exactly. This inherent majesty places it on a pedestal above purely local, terrestrial, or, ephemeral studies. Those are concerned with things that decay and pass away. The heavens, by contrast, seem to embody perpetuity.
That's a powerful starting point. It's not dignified because it's hard, but because of what it studies. Eternity, order, the whole of physical reality. Okay, so let's unpack this dignity a bit more. What about its methodology? What makes it such a perfect example of scientific synthesis?
The dignity is intrinsically linked to this requirement for synthesis, which he argues is pretty unique among the sciences. In Adler's framework, astronomy is the critical field where three things must interact and check one another: mathematics, observation, and metaphysics.
They have to work together.
They have to. It can't be a purely observational science. The complexity of planetary motion, for instance, requires extremely sophisticated mathematical modeling, geometry, algebra, and eventually calculus to predict motions you can't even see directly, like those retrograde loops.
The moments where a planet seems to move backward in the sky.
Exactly. But conversely, it can't be purely mathematical either, because those beautiful models have to be rigorously grounded in observation.
Right, they have to match reality.
Whether it's Babylonian record-keeping, Ptolemy's sighting instruments, or Galileo's telescope, observation is always the final reality check for mathematical elegance.
And the third piece of that puzzle, the metaphysics.
And that's the one you can't escape. The moment you define the nature of celestial matter, or you hypothesize about the shape of the cosmos, is it a sphere, is it flat, is it infinite, or you try to determine what causes the motion, you are making a definitive, non-empirical claim about the ultimate nature of reality. Astronomy forces the scientist to also be a philosopher.
That interaction, math, observation, metaphysics, that's the key. I get it now. It means any reader tracking this idea through the Syntopicon is simultaneously seeing the rigor of, say, Euclidean geometry and the immense fluidity of philosophical speculation, all in one conversation.
And the Syntopicon structure is the engine that makes that possible. The outline of topics for astronomy and the related idea of world links passages from authors across 2 millennia, from Homer and the pre-Socratics right up through the modern era. This structure lets you follow a continuous intellectual argument. You can literally watch how the answer to one generation's question becomes the foundation or the target for the next.
It's like watching an intellectual relay race, but the runners are using completely different equipment and sometimes speaking different languages. So what are the big, long-running debates that this lens allows us to follow, the really foundational ones?
We can trace 3 foundational debates continuously through the centuries. The first, and maybe the most famous because of its revolutionary outcome, is geocentrism versus heliocentrism.
The Earth-centered versus sun-centered model.
Right. But it's not just a spatial argument about what's in the middle. It's a profound argument about centrality, privilege, and human significance. If Earth is the center, well, then humanity is cosmically central.
But if the sun is the center, or if there's no center at all?
Our perceived status changes, fundamentally. The second big question is a finite versus an infinite universe.
Okay.
Does the cosmos end cleanly at the sphere of fixed stars? That idea implies order, limits, a kind of cosmic container.
Which might be comforting, in a way.
Or does it extend boundlessly, infinitely, which raises some radical theological and philosophical questions about the scope of creation and the nature of God?
And the third one?
The third is the foundational debate about the nature and status of celestial matter. Is the stuff of the heavens radically different from the stuff down here?
Like, is it made of something special?
Exactly. Is it composed of a perfect, immutable ether governed by perfect circular motions? Or is it fundamentally the same stuff as earth rock, dirt, gas obeying one set of unified physical laws? This question hits right at the root of classical metaphysics.
That third point, the status of celestial matter, that feels like where the metaphysical claims really start to clash with observation later on, especially when telescopes come into the picture.
Oh, absolutely.
But to really grasp the magnitude of that clash and why it was so revolutionary, we first have to establish that deep, two-sided classical baseline you mentioned.
Yes, we have to go back to the beginning of the argument.
That takes us directly to section 2, then. The classical foundations laid down by Plato and Aristotle. It really seems like the entire history of Western cosmological thought is just one long, complex argument structured by this crucial baseline divide they established.
It absolutely is. It is the defining split, and it's the reason Adler's Syntopicon gives equal conceptual weight to both viewpoints. They represent the 2 primary opposing ways the Western mind tried to impose and discover order in the heavens.
So for almost 2,000 years.
For nearly 2,000 years, every subsequent cosmology was either a refinement of one of these 2 or an attempt to synthesize them both.
Okay, let's start with Plato's vision. What did his account of the cosmos establish? I mean, particularly in terms of what he thought astronomy should be.
Plato established what we can call the metaphysical and transcendent view of astronomy. For Plato, the visible, physical stars and planets were not the ultimate reality.
They were just shadows on the cave wall, in a sense.
A perfect analogy. The heavens were seen as merely mirroring eternal, ideal forms, perfect, intelligible mathematical relationships that exist outside of space, time, and physical decay.
So Plato wasn't really interested in measuring the precise path of Mars as a physical object. He was more interested in using Mars's path as an imperfect illustration of the perfect geometry underlying it.
Precisely. The pursuit of astronomy, for him, serves as a rigorous route to contemplating intelligible order beyond the visible world. It's a training ground for the philosopher's soul. It's necessary to move the mind from the shadows of appearance to the true light of mathematical truth.
And the source points us to a couple of key texts for this, right?
Yes, the Timaeus, where he constructs a whole cosmology based on harmonic mathematical ratios and geometric shapes, and of course, Republic Book 7.
Ah, Republic 7, the famous cave analogy. That section frames astronomical study as necessary for the philosopher king to grasp the form of the good.
It does, and his discussion of mathematicals there is key. The actual physical heavens, the messy, observable reality, are secondary. What matters is the mathematical truth they point toward, the unchangeable, perfect structure. You study the stars not to know the stars, but to purify your intellect.
Okay, a very abstract, top-down approach. Now, let's pivot to Aristotle. He was Plato's student but took a radically different path. He was the great synthesizer of the physical world, adopting what we call the immanent view. How did his cosmology differ so fundamentally from Plato's transcendence?
The Aristotelian approach is, well, it's dramatically different. It is teleological, so it's focused entirely on inherent purpose, or telos, and it's immanent.
Meaning the truth is found within the world, not beyond it.
Exactly. The truth is contained entirely within the observable physical world. Aristotle looked at the heavens and concluded that the structure he observed demonstrated the natural, inherent motions and eternal purposes of the celestial substances themselves.
So to understand his view, you have to get this concept of the fifth element, the ether, right?
You absolutely have to. Unlike our four terrestrial elements, earth, water, air, and fire ether was perfect, eternal, and its natural motion was circular motion.
And why circular motion specifically?
Because it wasn't just an explanation for movement. It was the perfect explanation. Circular motion is eternal. It has no beginning or end, and it's perfectly self-contained.
So he wasn't looking past the celestial spheres for some higher, separate mathematical form. He was looking at the spheres to understand their natural, perfect, and inherent motion. The physical mechanism is the truth for him.
Exactly. For Aristotle, the cosmos was finite. It was structured by this vast system of interlocking celestial spheres. You can picture them like giant crystal gears that moved perfectly in circles because that was the inherent eternal purpose of the ether that composed them.
And we see this laid out in his major works.
Oh, yes. It's studied extensively in works like On the Heavens and Physics, which detail the necessary causes and principles of motion for both the terrestrial and the celestial realms. He built a complete system.
So if I were to summarize the difference then, the Platonic heavens are perfect because they reflect an eternal, non-physical mathematical truth. But the Aristotelian heavens are perfect because the inherent, observable, physical substances that compose them are eternal and move toward their perfect purpose, their telos.
That is the source of the continuous tension that defined Western cosmology for centuries. Is the order we see a reflection of a higher, separate, purely intelligible reality, which requires intellectual transcendence, like Plato thought? Or is it the inherent, observable purpose and structure of the physical substances themselves, which requires detailed empirical classification and analysis, like Aristotle thought? Every major cosmological debate that followed, including the huge fight over Copernicus, had to grapple with which of these two camps they were fundamentally borrowing from.
That tension certainly didn't just disappear. In many ways, it became the intellectual scaffolding for everything that came next. So let's move into Section 3 and track that historical development right after the foundational classical divide.
Well, the period immediately following the classical era, so Hellenistic and medieval, is characterized less by radical innovation and more by, I'd say, brilliant preservation and incredibly complex revision.
So their job wasn't to invent something new, but to make the old systems work better.
Essentially, yes. Their task was to make the increasingly detailed, observable phenomena fit within the existing, rigid, classical frameworks, particularly the Aristotelian one, because it was so systematic and, frankly, so satisfying.
But how did they manage that preservation while also accounting for the messiness of observation? Because, as we said, the planets don't just move in perfect circles. They seem to stop, reverse direction, and then move forward again. That's a huge problem for Aristotle's model.
That is the central problem they had to solve. And the Hellenistic period provided these sophisticated mathematical fix, most notably through the Ptolemaic models.
Called them.
Claudius Ptolemy. He was a master mathematician and astronomer who realized that to maintain the metaphysical requirement for circular, uniform motion, he had to introduce a lot of complexity.
What kind of complexity?
He needed to account for that apparent retrograde motion. His solution involved introducing epicycles and deference. So the planet moves in a small circle, that's the epicycle.
Okay.
And that small circle in turn moves along a larger circle, the deferent, which is centered near the Earth. This highly complex system was a mathematical marvel.
And
Crucially, it preserved the integrity of the classical, finite, geocentric cosmos while maintaining astonishing predictive accuracy. For centuries, it worked.
I wonder how that sits with the goal of finding order, though. You're adding complexity, a mechanism on top of a mechanism, just to save the core idea that the Earth is stationary. It sounds a bit like mathematical genius being used to protect a philosophical bias.
That's a brilliant way to frame it. It was absolutely mathematical genius in service of metaphysics. And when the medieval period inherited this system, it just solidified the whole arrangement.
And this is where theology comes in.
This is where the powerful Christian syntheses come in. Key figures like Thomas Aquinas integrated the highly systematic Aristotle and, to a lesser extent, Plato with Christian theology.
And Aristotle's model was a good fit.
It was a perfect fit for Christian doctrine. It was finite, it was ordered, it had distinct realms, a corruptible earth below, an eternal heaven above, and it provided a definite, absolute place for God as the unmoved mover, just outside the outermost sphere.
So astronomy became completely interwoven with the structure of the cosmos as created and governed by God. That ordered, finite universe must have provided immense existential comfort.
It did.
That fusion Ptolemy's math married to Aquinas' theology that defined the accepted world picture for centuries. To challenge it was to challenge, well, everything. Science, philosophy, religion.
Everything. But then came the early modern revolution and what Adler calls the Great Reversal.
And this reversal is just dramatic. It shatters the philosophical structure that was built up over 2 millennia.
Completely. The work of Copernicus, Kepler, Galileo, and Newton fundamentally reshaped astronomy. It stopped being a branch of metaphysics primarily concerned with ideal forms and inherent purposes.
And became?
And became a mathematically formulated, experimentally grounded, and mechanical science.
We all know Copernicus shifted the center from the Earth to the sun. But that wasn't the philosophical reversal itself, was it? It seems like it was the work that came after that truly broke the classical system.
Exactly right. Copernicus provided the initial spark by shifting the observer from the center. But it was Kepler who was the first to break the sacred rule of circular perfection by introducing elliptical motion.
That must have been a metaphysical earthquake.
It was. Kepler found that the mathematics worked perfectly only if he abandoned the circular telos of the heavens. He gave up the philosophy to follow the math.
And then came Galileo.
Then Galileo used the telescope to challenge the perfection of the celestial matter itself. By observing sunspots and the mountainous, imperfect surface of the moon, he argued that the heavens were not composed of perfect, unchangeable ether.
But were made of the same kind of stuff as Earth.
Similar stuff, yes, contradicting Aristotle's fundamental split between the two realms.
And then the final stroke, Newton, who unified celestial and terrestrial dynamics under a single universal law of gravity. That, I think, is the key insight we have to pause on, the universality of law.
That unification is the absolute heart of the reversal, the insight that physical law is truly universal, not dual. Newton demonstrated that the force causing an apple to fall in his garden is the exact same force keeping the moon in orbit around the Earth.
Which just demolishes the Aristotelian divide. That core metaphysical claim that was required to sustain the perfect circular motions of the heavens, it's just gone.
It's gone. The insight isn't just that the math is better. The insight is that the universe is governed by one set of rules everywhere. This moves the whole conversation from what is the inherent purpose of this substance, which is teleology, to what mathematical force governs the movement of this substance, which is mechanism.
And that fundamental shift in the question from asking why things move to asking how they move.
How much they move, even.
That's why Adler uses astronomy as his premier test case for epistemology. The discipline that asks, how do we know what we know? And how do we measure intellectual progress?
Precisely.
The scale of that historical change, moving from a comfortable, finite cosmos to a potentially infinite, mathematically governed one, is just staggering. It really does require a pause just to absorb the magnitude of that intellectual transformation.
It does, and we encourage all our listeners to seek out deeper context for these historical shifts, especially the philosophical implications of mechanism replacing teleology. Remember to check out the content on Mindful Moments. That's our YouTube channel offering AI essay analysis, summaries, and critiques. It's designed for inspiring reflection and rational thought.
A great place to slow down and really absorb the scope of these intellectual revolutions.
Exactly, and the sheer volume of material that Adler has synthesized for us.
That brings us perfectly to Section 4, focusing on Adler's epistemic and logical lens. This is where astronomy, the historical science, becomes astronomy, the universal philosophical test case for evaluating truth itself.
Right. In the Adlerian framework, astronomy serves as a primary test case for epistemology. Historically, we've observed humanity moving from, just guessing about the stars to genuinely understanding the principles that govern them. Adler's framework is designed to measure that progress logically and systematically in any field.
And he breaks this progression down into 4 very distinct logical stages of knowing. These stages are vital because they allow us to categorize and evaluate the status of any claim, past or present. Let's walk through them, starting at the lowest rung.
We begin with opinion. This is the starting point. It's comprised of myths, pure conjecture, and speculative cosmologies. This would include pre-scientific worldviews where celestial events are governed by arbitrary gods of forces.
Or just early, untested philosophical guesses.
Exactly. It's belief without demonstrated, reproducible proof or any real predictive power. Think of early astrology, the belief that the stars influence fate, as a system of opinion.
Okay, so opinion is replaced by a higher standard. Next, we move into knowledge. What differentiates knowledge from mere opinion?
Knowledge is marked by the movement to predictive mathematical models. Think of early Babylonian astronomy, focused on calculating lunar cycles, or the Ptolemaic system we just discussed.
So they might not have understood why the cosmos worked that way? They didn't have a theory of gravity?
Not at all. But their models allowed them to accurately predict where a planet would be on a given date. Knowledge is descriptive, it's functional, and it possesses immediate practical utility. But it is not fully explanatory.
That's already a massive leap, though, moving from superstition to reliable prediction. But the next stage, understanding, that seems to be what the modern scientific revolution, led by figures like Newton, truly achieved.
Absolutely. Understanding involves integrating astronomy with broader fields. It's when the discipline is no longer just predicting motions, but explaining them through a unified system of causes and principles.
You connect the dots.
You connect all the dots. The motion is explained through physics, like Newton's laws. The structure implies metaphysics, defining the absolute nature of space and time. And historically, it required a fit with theology or cosmology, defining the scope of creation. Understanding means grasping the causes and principles, not just the observations.
And finally, the highest stage, wisdom. If you already understand the principles, what does wisdom add to that?
Wisdom is the final philosophical stage. It involves judging what these discoveries imply about human place and purpose.
It's the so what question.
It is the ultimate so what. It's the application step. Having understood the mechanical workings of the cosmos, what does that new structure say, a potentially infinite deterministic Newtonian universe, tell us about human dignity, freedom, moral meaning, and the possibility of human agency. It's the moral and existential application of astronomical truth.
So astronomy forces us to progress logically through these 4 increasingly rigorous levels of intellectual certainty, culminating in applying truth to life. This structure itself is invaluable for evaluating any field of human inquiry.
It is. And to help with that evaluation, Adler insists we have to apply 3 specific, rigorous tests of truth. These are designed to vet claims made across those stages, especially when you have competing theories, like they did during the geocentric versus heliocentric shift.
Okay, let's define Adler's 3 truth tests. The first one, correspondence, sounds like the most straightforward. It's the empirical test.
The first test is correspondence. This is the fundamental empirical test. Do the theoretical predictions match observation? This is the test Ptolemy passed for centuries, and the one that observers like Tycho Brahe and Galileo started to challenge.
Do the epicycles really account for the planetary motions perfectly?
Can Kepler's elliptical model predict where Mars will be with greater accuracy? This test is the necessary bedrock. If a theory doesn't correspond to reality, it is, or at least should be, immediately discarded.
The second test, coherence, is less empirical and more systemic. This sounds like the most difficult test to pass.
Coherence is the systematic test. It asks, does the cosmology fit logically and consistently with broader physics, mathematics, and metaphysics? A system fails the coherence test if it requires 2 sets of mutually exclusive laws.
One for the heavens and one for Earth, like Aristotle's system.
Exactly. Newton's genius, in the Adlerian view, was achieving supreme coherence by unifying the laws of motion into one system that applied equally to falling apples and orbiting moons. If a cosmological claim contradicts established, well-proven laws in other disciplines, it fundamentally lacks coherence and can't be fully accepted as truth.
That's a powerful standard. So if we were to apply this outside of astronomy, say, to an economic theory, the correspondence test might be, did the economy actually grow as predicted? But the coherence test would be, does this theory contradict established principles of, say, human psychology or known historical patterns?
Precisely. You've just successfully moved it from the abstract to the tangible, and the third test is pragmatic success. the utility test.
Okay, so how is that different from correspondence?
Pragmatic success is essential because knowledge must be useful to be fully validated. Does the theory successfully guide practical applications?
The utility test.
Does the theory allow for better navigation at sea, better calendar making? Does it lead to technological innovation that improves life or predictive capability? If a cosmological model is mathematically elegant and coherent but ultimately useless for any real-world application, it fails the pragmatic test.
I see.
The shift from classical to early modern astronomy was fueled not just by beautiful observation, but by the very pragmatic need for better accuracy in timing and ocean navigation.
What's so great for you, the listener, is that this logical lens, the 4 stages of knowing, the 3 tests of truth, provides this robust intellectual structure for evaluating any complex information you encounter, using astronomy as this historical, rigorous example of applying criteria.
Absolutely. When you encounter a new, complex claim in any domain, be it history, technology, or social science, you can run it through these filters. Does it just correspond to some facts, or is it also coherent with our broader understanding of reality? And does it possess pragmatic success, offering genuine utility? That systematic, critical approach is really the lasting value of Adler's framework.
We've established that astronomy is a test case for knowledge itself. But the analysis doesn't stop at physics or epistemology. Now we hit the final and, I have to say, genuinely surprising transition. The framework forces us to move from planetary motion to the ethical and civic implications of cosmology. Wait, we're talking about Kepler, and now we're evaluating governance. How exactly does the order of the heavens translate into securing the blessings of liberty?
It is the ultimate measure of wisdom in the Syntopicon framework. Adler insists that no idea, no matter how remote it seems, exists in a vacuum. Once we determine the structure of the universe, that structure informs or threatens our most foundational understanding of ourselves, our dignity, and our responsibilities toward others.
Okay, so how does the framework apply the golden rule to the stars? That feels like a massive conceptual leap.
It addresses the golden rule by asking this question. How do these different cosmological pictures, say the geocentric cosmos where humans are centrally privileged versus the potentially infinite centerless universe, how do they support or undermine fundamental human characteristics like dignity, responsibility, or humility?
So if your worldview makes human beings insignificant accidents in a vast, uncaring void,
does that undermine the basis for moral responsibility? Does it undermine the justification for our political institutions? The framework forces a judgment here. If a cosmology implies that humans are merely fated pawns of planetary motions, astrology, for example, that undermines agency.
and the golden rule question would be,
Would you accept a society governed by fatalism? The golden rule here forces us to judge the ethical output of the cosmological picture. Is this a view of reality that fosters human dignity and moral action? It is a judgment of practical philosophy that flows directly from the theoretical science.
that is a tremendously high bar. It's asking if the theoretical truth is good for us, in the sense of supporting our moral life. Moving from that individual ethical test, the framework also invites what you call a preamble-style civic evaluation. This moves from the individual's moral choice to the collective societal structure.
Yes, the civic evaluation asks if the cosmological outlook fosters the kind of shared, rational thought necessary for a functioning republic. Cosmological outlooks are judged based on whether they encourage a shared, rational world picture.
Meaning, does the accepted understanding of the universe align with reason, allowing citizens to communicate and cooperate effectively because they share an objective reality?
Exactly. And then, does that shared rationality support the goals articulated in foundational civic documents? Does a certain cosmological outlook promote the general welfare and secure the blessings of liberty?
How could it do that?
Well, if the accepted view of the cosmos implies that human beings are fundamentally irrational, or that the world is chaotic and unpredictable, how can you possibly structure a government based on rational self-rule?
You can't.
The civic test is whether the scientific worldview supports the necessary intellectual ground for liberty and welfare. A worldview that promotes certainty, intelligibility, and human agency supports liberty. The discovery of universal, rational laws of motion, paradoxically, provided the intellectual foundation for a belief in universal, rational laws of governance.
And conversely, what's the ultimate danger that Adler's framework contrasts this rational civic outlook with?
The danger is that certain world pictures foster superstition and fatalism. If people believe that their fate is sealed by arbitrary celestial mechanics, or that they're constantly subject to unknowable supernatural forces, that fundamentally hinders thoughtful self-government.
I see.
A population that's paralyzed by superstition or fatalism is incapable of taking rational, collective action to improve their conditions or manage their civic responsibilities. So the transition from astrology, which is fatalism, to modern mathematical astronomy, which enables mechanism and agency, is presented as a major civic and ethical victory in this framework.
This analysis really does demonstrate Adler's ultimate genius.
Right.
Using the most abstract science imaginable, astronomy, focused on things millions of miles away, to force these foundational immediate questions about human governance and morality right here on Earth. The theoretical becomes practical instantly.
It connects the structure of the stars to the potential structure of the state. It insists that what we believe about the objective cosmos dictates what we believe about our subjective selves, and therefore how we should organize our lives and our societies in pursuit of justice and liberty.
So to synthesize this immensely rich intellectual journey, our analysis of Adler's introductory essay on astronomy really showed us how the field evolves so dramatically. It began as this metaphysical contemplation, rooted in the tension between Platonic transcendence and Aristotelian immanence, then shifted to a purely mathematically formulated science by the early modern period, and then finally it returned to serve as a philosophical touchstone for judging human wisdom and ethics, all through the lens of the 4 stages of knowing and those 3 crucial truth tests.
We've seen that the challenge of understanding the physical heavens is intrinsically linked to understanding our own intellectual capabilities and ultimately our moral obligations within a universe whose structure we are constantly redefining.
Before we wrap up, we want to leave you, the listener, with a final provocative thought to mull over. We discussed the 3 truth tests: correspondence, coherence, and pragmatic success. These were crucial during that shift from Ptolemy to Newton.
So the question for you is this. Which of those 3 tests do you believe carries the most weight in modern scientific discovery today, and why? Do we currently prioritize what works, what fits with everything else, or what simply matches observation?
Click the link on screen for the in-depth essay summary, subscribe, share, purchase via link, and think rationally.
We thank you for joining us for this extensive analysis of one of the great ideas.
See the many genre-based essay podcasts at Mindful Moments. Nourish your mind on the go.